All right, so this is a lecture over 7.1 through 7.3. I'm combining them all into one lesson. They're all about law of sines and cosines, which you've had some exposure to in geometry and maybe even algebra 2. So I think it's almost easier to understand if you just put them all in the same lesson. So our learning intention is to understand properties of non-right triangles, and our success criteria for these lessons specifically, is to solve non-right triangles. So this whole semester we've been dealing with right triangles. This chapter deals with non-right triangles and how to find their missing parts. All right, so that being said, here's what you did basically when you had a right triangle. You set it up A, B, C. Typically, C was the hypotenuse. Notice the angle is always across from the corresponding side, and we used SOHCAHTOA to solve triangles that look like this. In this chapter, we're going to be dealing with triangles that look like this, where there is no right angle. We will still label them angles A, B, and C. Noticing that same process here as the angle will always be across from its corresponding side. Lowercase b refers to the side that's across from angle B, and that will be the case no matter what. And it doesn't have to be A's, B's, and C's. It can be J, JKL, or M and O, any three letters. However, you always name the side opposite that angle with the lowercase letter. All right, so law of sines and cosines I have written up here. This is the law of sines, and this is the law of cosines. Now, these can be found on the inside front cover of your textbook as well, the same page you've been looking at for Chapter 5. I think the lower right-hand corner is for Chapter 7. And so, law of sines basically sets ratios equal to. It says if you take the sine of this angle over its corresponding side, then you can set that equal to the sine of one of the other angles over its corresponding side. So it doesn't matter, you can use any two of the three to set up a proportion. In order to be able to use law of sines, you've got to have a pair. You've got to have an angle and its corresponding side. If you don't have that, you cannot use law of sines. So if you know angle B and lowercase b, then you can use law of sines. If you know angle C and its corresponding side, just so as you have one pair. If you've got one pair, then you definitely want to use law of sines. You can use a pair with law of cosines, but it's really a pain and a lot more difficult problem that ends up with a crazy quadratic formula problem. So always use law of sines if you've been given a pair. Now, in order to solve non-right triangles, they've got to give you three items. In right triangles, you only had to have two. You had to have an angle and a side or two sides to find all the missing parts. And I guess when you think about the fact that you knew the 90-degree angle in these, I mean, you were always given two items, but you always knew this one. So really, you knew three items about those. So here, you've got to be given three items, and then once they give you those three, you can find the other three. Law of cosines looks like this. And law of cosines can be written with, notice it only has one angle measure. Whatever the angle measure you know, that's the angle that goes here. But it doesn't have to be angle A. If you know angle B, that's not a problem. You just put angle B here, and the corresponding side always goes here. So whatever angle this is, the corresponding side must go here, and the other two sides go here and here. Notice these two letters are the same as this. Notice this, and as far as trying to memorize this thing, this just looks like Pythagorean theorem. Whatever this side is, that corresponding angle will be over here, and these two letters always match these. So if you've got an angle B here, that means you would put B here, and then A and C would go here. Now, if you want to use law of cosines to solve for an angle, we can rearrange this entire equation and solve it for cosine A. In other words, get this by itself. So if I get this by itself, that means I would need to move these two terms over to the other side, which is where I got this. And then notice this part right here is multiplied times cosine A. So to get rid of it, I would have to divide by it. So that's why I have this divide by negative 2bc. So this is basically an equation where if you're looking for an angle measure and you know all three sides, then you can plug all three sides in here, work this out, and then do an inverse cosine problem. So these are the two forms of the law of cosines, and you can always adjust them depending on what angle you're looking for. If you know angle B, then adjust these accordingly. If you know angle C, then C goes here. That means this is lowercase c, and then these are A and B. And then same thing here. If you're looking for angle C, not a problem. The corresponding angle to this is right here. So if this is a angle C, then side C goes here, and the other two sides go here. All right, so now that we've got that, let's look at our some possible examples. I know I said back here that the author of the book has got to give you 3 items in order to be able to solve for the other 3. Well, that's true, except for in this case. Remember that they can't give you 3 angles, because if they give you 3 angles, it could be a really tiny triangle, really large triangle with those 3 angles. Just like a 30, 60, 90, you can have a really small one, a really large one. That just would mean the 2 triangles are similar. So it would be impossible to give you 3 angles because there's, a million different triangles that would exist, really small to really big ones. So that's not an option. Okay, now, if they give you 3 sides, remember that in order to use this one, you must have a pair, an angle and its corresponding sides. So if you're doing side, 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 guaranteed you got to use law of cosines because you don't have a pair. So side, side, side means they give you all 3 of these. No pair, so you cannot use law of sines. Okay, this one, if you've been given a side, an angle, and a side, that means they're giving you 2 sides with the angle included. So it could be any 2 sides as long as the angle between them is the angle you're talking about. So that might be side, angle, side. This angle is touching both sides. That's what side, angle, side means. If they give you 2 sides and the angle that's touching both of them, called the included angle, then that would be a case of side, angle, side. And notice, we don't have a pair here. I don't know angle B, so I can't use this as a pair. I don't know angle C, so I can't use this as a pair. And I do not know side A, so I can't use this as a pair. So if you don't have a side, that means you are forced, if you don't have a pair, you are forced to use law of cosines. Law of sines will not work. All right, let's say they gave you angle, side, angle. Angle, side, angle means they're giving you 2 angles and the side that's included between the 2 angles. So maybe they're giving you this. Maybe they're giving you angle, this angle, and the side in between them. That's what we call side, or angle, side, angle, because this side touches both of these angles. You wouldn't want to use this side over here because it doesn't touch angle A. So angle, side, angle. So if you have angle, side, angle, let's see, what do we have there? I don't have a pair right off the bat, but look, if you know 2 angles, you can easily find the third one. So I could add these 2 angles up, subtract from 180, and if I did that, then I would know angle C, and now I have a pair. And as long as you have a pair, you're allowed to use law of sines. And law of sines is a little easier, so if you can use law of sines, that's the way to go. So anytime they give you 2 angles, you're going to add them up, subtract from 180 to find the third, so that you do have that pair. All right, what if they give you angle, angle, side? Angle, angle, side means they're giving you 2 angles and a side that's not in between the 2 angles. So they're giving you an angle, and then a side that doesn't touch both. It can touch one, but not both. So it could be this side, it could be this side, but it could not be this side in order to be angle, angle, side. So we can have angle, angle, side, or we could have angle, angle, side. So do I have a pair? I do. I have angle A and the side that's across from it. So anytime I have a pair, I want to use law of sines. So that would definitely be a law of sines problem. All right, now, with these last 4 that we've talked about, side, 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 angle, and side, side, angle, Those, in all cases, if you remember back from geometry, a lot of times you would be given an angle side, and you had to prove that two triangles would be congruent if given this, because and the reason why is no other triangle can exist. If you've been given two angles and a side, it's impossible for two triangles to exist under those circumstances. And same with all four of these. Only one unique triangle exists. But if you have this one, side-side angle, this is the weird, ambiguous case one where multiple possibilities exist. In other words, if I give everybody in the class one specific angle measure and two straws that were different lengths, some of you would come up with one triangle, some of you would come up with another, because it's possible that two triangles exist. And there's actually three cases to this, so that's why I have 1, 2, and 3 here. But just to make sure you understand what side-side angle is, that would mean that you're given two sides and an angle that's not included. So it could be this angle or it could be this angle, but you have two sides and an angle not included between them. So case one, here's case one. Let's say I have a 30-degree angle, and so I give everybody in the room a 30-degree angle requirement, and then I give you straws of length 6 and 2. It would be impossible for you to come up with a triangle for that, okay? Because if you think about the 30-degree angle, hooking the 6 to it, and then dangling a 2, this straw right here, no matter how I swing this one, because I don't have any criteria for this angle, this one right here could swing in any direction, but it would never touch this side down here that's hooked to the 30-degree angle. So this one's impossible. It is impossible to make a triangle with a 30-degree angle, a 6, and a 2. So in that case, it would be no solution. What if I gave everybody a 30-degree angle and two straws of length 6 inches and 4 inches? In this case, it's possible to get two different triangles, because this angle is set. I can't change it, but I can change this angle up here. I can swing this side, take this side, and hinge it one way or the other. Well, if I take this thing and I hinge it this way, I get this triangle. If I take this thing and I hinge it out this way, then I get this triangle. So in this case, two different triangles that exist. And then the other case scenario would be, what if I give you a 30-degree angle, the 6-inch straw, and let's say this one over here is a 12-inch straw. It's long. So it's really long, and so clearly I can't hinge it this way because I would run out of room as far as hooking over to this side. But I can take it and make this angle big and hinge it over this way and make a triangle that looks like this. So that now this is 12 and this is 6. And I probably ran out of room there to make that as long as it needed to be, but you kind of get the picture. So in this case, there's only one triangle that exists. So anytime they give you side-side angle, red flags should be going off in your head, saying, oh my gosh, this is the crazy one. Now the good thing about it is you always will have a pair, so you definitely can use law of sines. But it's going to be crazy because we don't know right off the bat, is this the one where no triangle exists? Are they giving me something where two triangles exist? Or are they giving me the one where only one triangle exists? And we'll do an example like that here in a little bit to go over those possibilities and how to figure that out. All right, so here's our first example, our example 1. And anytime you do one of these problems, law of sines or cosines, we always want to start out with this. We have a picture of a triangle labeled ABC with the sides across from it. And I have each labeled over here. I have ABC angles and ABC. So this is what they're going to give you in the book, something that looks like this. And we're going to fill in and see what we know and then find all the missing parts. So let's see, what do I know? I know that angle A is 42.5, so I'll put that here. I always start with this blank case scenario. Angle B is 71.4, so I know this one. And letter A is 215. All right, so I know angle A, I know angle B, and I know side A. So the first thing you want to ask yourself is, do we have a pair? Sure enough, I have a pair. I need to find these parts. I need to find angle C, side C, and lowercase b. You're finding all the missing parts. So, since I have a pair, that's your first indication. You want to use law of sines. Okay, now, what do I have here? This one's angle, angle, side. Because I do not have the included, so we call this angle, angle, side. So that's the easy one. That's not the crazy one. Remember, the crazy one that causes you problems is a bad word if you spell it the other way around. So ASS spells a bad word. So it's the one that spells a bad word if you turn it around that causes you problems. So you know when you see angle, angle, side doesn't, I have a pair, doesn't spell a bad word, so this is an easy one. So I'm just going to use law signs. I remember what law signs is. Law signs says that the sine of angle A over lowercase a is equal to the sine of B over lowercase b is equal to the sine of C over lowercase c. Now these could be inverted. If you'd rather put the sides on top and the signs on the bottom, that's fine. It won't matter if you're flipping it over. It's just like if you have 1/2 equals 4/8, that's a proportion. That's no different than saying 2 over 1 is equivalent to 8 over 4. Right, so the cross product's still equal. So if you would rather flip them over, you can absolutely do that. All right, so I have a pair with A, so I'm definitely going to use this one. And let's see, what else do I know? I know angle B, so I know angle B, so I'm going to use these two. I'm not going to use this one to start off with. So I know that the sine of A is 42.5, and I probably should just rewrite that. Sine of 42.5 over A, which is 215, is equal to the sine of angle B, and I do not, I know B, I do, it's sine of 71.4 over lowercase b, which I do not know. And so now I have a missing part. If you remember Mr. Bloodgood in middle school teaching you the fish method, that's basically what we got here. You got to take these two, multiply them together, and divide by this one. So you can do it all in one big swoop if you want, or you can cross multiply and divide. So theoretically in math, this times this is equal to this times this. So I would have b times the sine of 42.5 is equal to 215 times the sine of 71.4. So now to get the b by itself, you have to divide by the sine of 42.5. So 215 times the sine of 71.4 over the sine of 42.5. All right, and so on this one, there's nothing but multiplication and division here. You only have one item in your denominator, so you wouldn't even have to worry about parentheses in this one. The calculator is automatically going to do this first. Then when you hit divide, it will divide by this. So the big thing on these, all law of sines and cosine problems are in degrees, so you definitely want to make sure that your calculator is in degrees. So if we go type that in, keeping in mind they gave us 3 sig figs for every number, so we probably want to do that for our answer. All right, so when you type that in the calculator, my calculator came up with 301.6. So since we want 3 sig figs, I'm going to round that to 302. So that is B. So over here, B is 302. All right, now remember, I can easily find this other angle measure. The angles in any triangle add up to 180. So all I got to do to find angle C is add these two up and then subtract from 180. So typing that in the calculator, you will get an angle measure of 66.1 using 3 sig figs. Okay, so all we have left to find is side C. I now know everything except that, and so now I can go back and use law of sines again. This time, now that I know angle C, I can use this ratio with either one of these. This is the one we started off with, so I'm going to go with what the book gave me in the first place. So I will use this ratio with this one this time. So I'm just going to erase some of this. Just keeping that same ratio. So here's my sine of A over A. This time I'm going to set it equal to sine of C over C. And angle C we just figured out was 66.1. And so now I'm looking for lowercase c, and I'm going to go through the same process again. I'm going to take this times this and divide by that, kind of like the fish method like you learned from Mr. Bloodgood. If I'm looking for this one, the two that are across from each other get multiplied, and then I divide by this. So essentially, C ends up being 215 times the sine of 66.1 divided by the sine of 42.5. So type all of that in your calculator to find side C. And so my calculator gives me 290.95, so that would run to 291 if we do 3 sig figs. So side length C is 291. The only thing, as I said, you don't have to worry about adding any parentheses, but your calculator will automatically open up a parentheses here, so you do want to make sure you close that before you hit divide. So 291, and we have now solved this triangle. Every missing part has been found. All right, so let's look at this case. In this case, I've been given 2 angles and a side. Let's go over here to our picture. Remember, you always want to start with this picture, and these 6 items of the triangle left blank. And then this is what I know. This is what the book gave me. So I know angle B, I know angle C, and I know side length A. So this is a case of angle, side, angle, because the side is in between the angles and touching both angles. So it is, once again, angle, side, angle. And so let's fill in what we know. Angle B is 57 degrees. Angle C is 31 degrees. And side length A is 7.3 meters. Notice they're giving us 2 sig figs with each number, so that's how we'll report our answer, is with 2 sig figs. Now, when you look at the picture, right off the bat, we do not have a pair. I do not have a pair here, I do not have a pair here, I do not have a pair here. But remember, it's always easier to use law of sines, so you want to see if you can find a pair because you know 2 of the angle measures. So if you know 2 of the angle measures, we can add them up and subtract from 180 in order to find the 3rd angle measure. So if we add these together, I'll have 88. And if I take 180 minus 88, I will get 92. Okay, so 92 degrees is angle A, so now I know angle A, which means I have a pair. And if I have a pair, that means I can use law of sines. So the pair that I have is A, which is 92 degrees, over side length A, which is 7.3. Now I can use the same ratio with either B's or C's. So I know both of these angles. It doesn't really matter which one you pick. I guess I'll go with B first. So sine of B, which is 57, over lowercase b. So this was sine of A over lowercase a. Here's angle A and lowercase a. You have your pair. And sine of 57, that's angle B, so that means I'm looking for lowercase b. So here we go, fish method again. You're solving for B, so you just take this times this and divide by this. So lowercase b is going to be equal to 7.3 times the sine of 57 divided by the sine of 92. So type that in your calculator. All right, my calculator gave me 6.12, and I'm only looking for 2 sig figs, so I'm going to use 6.1 for my answer for B. 6.1 is B. All right, so now I simply have one side length left to find, so I'm once again going to come back to this proportion. I'll just erase this part and do the ratio for angle C. So I'm going to put angle C right here and lowercase c down here. So angle C is 31 degrees. I'm looking for lowercase c, so here we go again. Multiply these two and divide by this one. If you'd rather cross multiply, you can. C is going to be equal to 7.3 times the sine of 31 divided by the sine of 92. So type that in your calculator. All right, my calculator gave me 3.76, which rounds to 3.8. So my C value, 2 sig figs, I'm going to use 3.8. So 3.8 meters is what's missing. So half of the time the mistakes that get made on these problems is just typing them in the calculator. So you might want to practice typing them in with me. You could just hit pause, type it in, and make sure you get the same answer I do, just to make sure you're getting it typed in correctly. All right, next example. In this example, I have been given side length A, side length C, and angle B. So this time I have side, angle, side. I have two sides with the included angle, so we call that side, angle, side. And let's see, let's plug in, do I have a pair? It does not look like I have a pair. I do not have a pair of C's, I do not have a pair of A's, I do not have a pair of B's. So it's looking like a law of sines. I don't have any way to find these two angles, so it's looking like probably going to have to use law of cosines on this one. So A is 0.923. Whoops, that's side A, not angle A. And I know side C is 0.387, and angle B is 43 degrees and 20 minutes. All right, so no pairs. That means I'm stuck with law of cosines. So let's refresh our memory on what law of cosines is. Remember that whatever you put here for the angle measure, the opposite side is over here. So this is the basic formula for law of cosines. Minus 2 BC. These two always match these two, and this always makes a pair. Now, when you look at the information you know, we have angle B, not angle A, so that's no problem. I just rewrite this thing for an angle B. So if my angle is B, that means that I want lowercase b over here. And that means I want the other two letters here. So that would be the A and the C. And these two letters always match these two letters, so that's going to be an A and a C. So this is the version of law of cosines that I'm going to need to use. All right, so we want to fill in what we know. I know B, and I know A and C. So I'm going to be able to find lowercase b by plugging in the numbers. 0.923 squared plus C, which is 0.387 squared, and then I'm supposed to say minus 2 times A, which is 0.923, times C, which is 0.387, times the cosine of angle B, and angle B is 43 degrees and 20 minutes. So the cosine of 43 degrees, 20 minutes. So right there is all of the stuff I need to type in the calculator to get b squared. Now remember, we don't want to know b squared, we want to know b. So if I want to know b, I know I'm going to need to square root all that. So if you want to do all of this first and then square root your previous answer, you can. Or you can do the whole thing in one big swipe. It doesn't really matter either way. 92.3 squared plus 30. Oh, I got my decimal in the wrong place. Let's start that over. 0.923 squared plus 0.387 squared minus 2 times 0.923 times 0.387 times, see, this is a long one to write out, times the cosine of 43 degrees 20 minutes. Okay, so like I said, you can either type it in all from here and then square root your previous answer, or you can type it all in one big thing with the square root being here. So try typing that in as I type it in. Alright, so when I typed this in, I got a b value of 0.694 to 3 sig figs. 0.694. So that is what goes right here. All right, so I'm going to go back and put that in that spot. I will expand this. If you're struggling to get the correct answer in the Calculator, just double check everything. Make sure that this is a minus sign and not a negative. You don't really need to use parentheses anywhere in here other than right here for this. So I'm just using the times symbol in between those. Make sure your decimals are in the right place, your squareds are here, and that sort of thing. And that the square root is over the entire problem if you're doing it in one big sweep. All right, so let's expand this back at 0.694. So this is 0.694. And so the nice thing about that, to make that look a little better, is now we have a pair. So now that I have a pair, it's okay for me to go and use the law of sines. Now, one thing to remember about law of sines is you always want to avoid law of sines when you're finding the largest angle. So here's law of sines. You always need a pair to use it, and you always want to avoid it if you're finding the largest angle. So let's go back to our problem and make sure that we're not finding the largest angle. So I still need to find angle A and angle C. Well, do I know which angle of my three is the largest? Well, I should by looking at this, because remember that the largest angle is always across from the longest side. So this is clearly the longest side. And so the largest angle would be across from it. Remember, I want to avoid finding the largest angle when I'm using a law of sines. And the reason that is because whenever you use the calculator to do inverse sine, it will only give answers in the coffee cup handle. It will not give obtuse answers. However, it will do fine on acute angle. So I know that if I have an obtuse angle, it would have to be this one. So I'm going to opt to find angle C and not angle A. So find angle C, not angle A, since we want to avoid law of sines for the largest angle. All right, so here's all of my law of cosines work. I'm going to erase that. And I'm going to find angle C, since I know it's not the largest angle, using law of sines, because law of sines is always easier than law of cosines. So law of sines, remember your pair is your B angle, so I'll start off with a sine of B, which is 43 degrees and 20 minutes, over the side across from it, which is 0.694, and that is going to be equal to, remember I said I wanted to use C, so I'm going to find, I'm going to put lowercase c right here, 0.387 sine of C. So this time, I'm not solving for a side, I'm solving for an angle. So you may want to, we'll cross multiply just to make sure you know what we're doing there. So it's 0.694 times the sine of C is equal to 0.387 times the sine of 43 degrees and 20 minutes. Okay, so all I did was take this times this and set it equal to this times this. And now I'm trying to get sine C by itself, so I'm going to divide by this. So just take this, mark it off, divide by it on the other side, 0.694. Or we could have just used the fish method that you learned in middle school. This times this divided by this will give me this. All right, so I'm going to type this in the calculator, and then I'm going to do inverse sine to find this angle measure. Anytime you're looking for an angle measure, you tell the calculator to go backwards. So I will do inverse sine of my answer to this problem. Okay, so find this answer and then do the inverse sine of that. All right, so when I worked this out, I got a 0.3827, and now I'm doing inverse sine of that, or my previous answer. And when I do that, I get an angle measure of 22.5 if I'm doing 3 sig figs. So 22.5 degrees is my angle C, so I'll go back and write that right here, 22.5. And so now that I know these two, I can add them up and subtract from 180 to find this one. If you have forgotten where to find the degree and minutes symbols, to access those, you want to do second and the apps button. Because if you look right above on your calculator, the word apps right above it in orange is angle. So you do second apps to access that degree symbol and minute symbol so that you can do that. I guess you could have also made this 20 out of 60, which is a third, and then 43.3 as well. All right, so if I add these up and subtract from 180, all right, and so when you do that, you should get 114 degrees. And so there's your answer for angle A. And we have now found all the missing parts, so we are done with that problem. Okay, next example. This time you have, it looks like you've been given all sides. You know A, B, and C. So A, B, and C means you know all three sides. And if you know all three sides, clearly you don't have a pair or have any way of finding a pair. So we're going to have to use the law of cosines to find one of the angles. So A is 48, B is 75, and C is 63. So law of cosines, knowing all three sides, you basically have to figure out which angle you want to solve for first. So solving for which angle? Well, I know that I should never use law of sines to solve for the largest angle, so that means it's a good idea to use law of cosines. So when you've been given side, 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 man, let's get that largest angle out of the way and find it first. If you look at my three sides, clearly side B is the largest. So that means angle B is the one I want to find first, because I know when I get done with this, I'm going to want to use law of sines. I never want to use law of sines to solve for the largest angle, so let's get it out of the way right now with law of cosines. So if I want to find angle B, looking back at this sheet, remember that you can start with this one if you want and get it to this format, or you can start right with this format right here. So when you're looking for an angle measure, this is the format you're going to need. Here's your angle that you're looking for. Here is the one opposite, and then the other two angles go here. All right, so if we're going to do that, I am looking for angle B. So that means I'm going to put the cosine of angle B is going to equal lowercase b, those should match. And then the other two go next. It really does not matter which one you put where. Over -2 times those other two sides. All right, now let's talk about parentheses here because they are going to be very important. You're going to want to tell the calculator to do all this first because it would prefer to do division before it does subtraction. And your denominator, you're going to need to group all that together as well. So very important that you use parentheses for the numerator and the denominator, and then once you get that answer, you're going to do inverse cosine to find angle B. So inverse cosine of your previous answer. So find this answer and then do inverse cosine of that. All right, my calculator gave me 83.8, so I'm going to round that to 84 degrees. And so 84 degrees is my angle B, so I'll put that right here. And now I need to find the other two angles, and since I know that I have found the largest one, I can use law of sines. I have a pair now, so now I can go back and use law of sines. So to do that, let's sine of 84 degrees over its pair, which is a 75, and then you can basically pick whether you want to do angle A or angle C. I'll go with angle A. So I'm finding the sine of A, have to put it over the 48 since that's the pair that matches the other side that matches up with it. So now I simply need to take this times this and divide by 75 to figure out what the sine of A is. So this times this divided by this will equal sine of A. Looks like this, sine of A is equal to 48 sine 84 over 75. So type that in the calculator and then do inverse sine so that you'll know angle A. All right, so this part right here gives you a 0.636, and then you do inverse sine of that, and it rounds to 40 degrees. I got 39.5, round it to 2 decimal places, and we get 40 degrees. So I have 40 degrees here for angle A. Now the only thing left to find is angle C, and I can simply add these up and subtract from 180, so that'd be 124. So 180 minus 124 should be 56. 120. All right, and that's all for that problem. All right, next problem. You've been given these three items. So we know A, B, and capital A. So I know lowercase a, lowercase b, and I know angle A. So good news is I have a pair. So that means I can use law of sines. Bad news is this is side-side angle. So remember, side-side angle, when you spell it the other way, spells the bad word. And that's that crazy one where I have all those case scenarios. So I don't really know. Maybe it's going to be this one where the triangle doesn't even exist and I have to put no solution. Maybe it's this case scenario where I have to give two separate sets of answers. Or maybe it's this one where there's only one possible triangle that exists. So that's what I have to figure out. So I have to assume that there's possibly a second triangle. So I'm going to label, if I have a second triangle, that means I end up with 12 answers. So I'm going to call this triangle 1. And it's possible the second triangle exists. And we'll call it triangle 2. So A2, B2, C2. And a lower cases for all those as well. And let's fill in what we know here. We know A is 54, lowercase a, lowercase b is 62, and angle A is 40. I know that in both cases. So in both cases, I label those in there. So this is a 40, this one's a 54, and then this one is a 62. All right, so to start this problem, at least I do get to use law of sines. So I use law of sines, set this up as the sine of angle A, which is 40, over 54, and sine of B over 62. So using this pair and looking for this angle in whichever case this may be. So once again, fish method, I'm going to take this times this divided by this, and it's going to give me sine of B, and then I'll do inverse to get that out. But keep in mind that there's two positive answers for sine. Let's first of all just work out this times this divided by this and see what it gives us. All right, so when I actually multiply these together and divide by this, I get 0.7380. 0.7380, and that's equal to the sine of B. Take this times this and divide by this. But if you remember back from chapter 3, there's two answers to this problem. Sine is positive in two quadrants. It's positive wherever y is positive. So there's an answer here and here. So when I do inverse sine in the calculator, that's just giving me the reference angle, which gives me one possible answer. But if I subtract it from 180 to figure out what this one would be in this quadrant, then that could possibly be my second triangle. So let's do that. Let's do inverse sine of B and see what we get. So just inverse sine of your previous answer. And that gives us an angle measure of 47.5, which rounds to 48 degrees. So B is going to come out to be 48 degrees. Well, that's your answer in this quadrant, 48 degrees. But also there's one over here in this quadrant. And how would I get from here to here? I would take 180 minus 48 for that one. So 180 minus 48 So that gives me 132. And so now, notice I came up with two answers for angle B. So I did inverse sine of this to get the 48. I recognize that there's two answers to this problem, as I did in chapter 3. So sine is positive in these two quadrants. And so to get my angle that's in this quadrant, I have to take 180 minus the 48-degree reference angle to figure out how far it is from here to here. All right, so what that tells me is in this triangle up here, I have a 48-degree angle for B, and I do in fact have a second triangle where B is a 132. Alright, so now I have to go back and solve for these four missing parts in these two in each triangle. So to find these two, I simply add up and subtract from 180. To find this angle C, add up and subtract from 180 to find this one, and then I can use law of sines to find my missing side. So if you add these two together, you get 88. So that means this angle is going to come out to be 92 degrees. And on this one, if I add these up, 132 plus 40 is 172. So that means this angle is only 8 degrees. So now I'm going to need to use law of sines again to figure out this and this. So there are two possible triangles that exist from this side-side angle. All right, so let's do our law of sines. So you essentially end up using law of sines 3 times here. So I've got, let's work with the blue triangle, the one in blue first. So I have got my pair being here. Sine of 40 over 54 is equal to the sine of angle C, which is 92, over C1, which is what I'm trying to figure out. Okay, so multiply these together, divide by sine 40, and you'll have your answer for C1. All right, so C1 comes out to be 84 degrees. So that's what we put here. All right, now I need to do the same thing for this one, so I just need to go back. And I still have this same pair that I started with, 40 and 54, so I can use this. I just need to change this over here. So for the triangle that's in red, I am going to have the sine of 8 degrees over C2 to find C2. So now type that in your calculator. All right, so if we type in 54 times the sine of 8 and then divide by the sine of 40, we will get 11.69, which rounds to 12. So C2 in my second triangle, C2 is going to equal 12. So I go back here, put a 12, and now I have the two possible triangles that would exist from this side-side angle that I have been given. All right, so for this example, we know, and if you are at a point where you feel like you can do the homework without these last two examples, it's just the last two cases of a side-side angle, so however you feel about that. But anyway, of what we know here, we know side A, side C, and angle C. So once again, we have side-side angle. That's the one that spells the bad word. So which case is it? Is it... we already had one that had this case, so is it this one where the side's too short? If it is, you'll get a no solution. Or is it this one where it's really long and it can only swing one way to make a triangle? All right, so fill in what we know. A is 205, C is 314, and angle C is 35.4. So there's your pair. So we use our pair to do law of sines. Sine of 35.4 degrees over the side opposite, which is 314. And I know angle A, so I'm going to want to use that one. Sine of 205 over little a. So I want to take this times this and multiply it together and divide by this. So when you take this times this and divide by this, you end up with a negative answer for A, which is impossible. A length can never be negative, so that's how you know that this is a no solution problem, because little a cannot be negative. So it's the case where that one side was too short and just swings back and forth. All right, and the last example, this one you know, angle A, you know lowercase b and lowercase a. So here's your pair, and once again it's a case of side, side, angle. The angle is not included between the two, so that's the one that spells the bad word. So we have to see which case is this. 142, 1.4, and 2.9. So let's group our pair together. Our pair sine of 142 over 1.4 is equal to the sine of angle B over 2.9. So this is that case where I maybe will have a second triangle. And so I should probably make room for that second triangle. So let's move this out of the way. And we'll say triangle 2. All right, so because whenever we do a problem like this, we know there's going to be two answers because sine is positive in both quadrants. So let's see what happens on this one if I multiply and divide. All right, so when you multiply these two together and divide by 1.4, you will get an angle of B equaling, or sine of B, I should say. Sine of B comes out to be 1.28. When you take this times this and divide it by 1.4, you get 1.28. So from here we would typically do an inverse sine, but if you do inverse sine of this number, you'll get an error. Because remember, sine is opposite over hypotenuse, and the opposite can never be bigger than the hypotenuse, so it's impossible to get a number bigger than 1 on an inverse sine problem. So when you type this in the calculator, you are going to get an error, which means that this problem is no solution also. This one, anytime this number is bigger than 1, then it's impossible to find angle B, and that means that not only did the second triangle not exist, neither did the first one. There is no triangle that will exist with that criteria. And that being said, thinking back to that last one I just did, where I made a mistake somewhere, because this one should not have come out no solution. On this one, I messed up. Right here, this is little a equals 205, and I put it for big A over here. So if I go back and correct that, take the 205 and put it here. And looks like I got these backwards also. This is a 35.4 degree angle and a side length of 314. So if I correct those, looks like I got this correct here, but the 205 should have been down here. So that would be sine of angle A over 205. And so now, if I type that in the calculator, what will I get for sine of A? All right, and so if you do inverse sine of 0.378, you get a 22.2 degree angle. So here we get 22.2. Now remember, there's always that second angle you can do, because when you do an inverse sine problem, there's two answers. There's one here and one here. And so the 22.2 is the reference angle. What would that be over in this quadrant? So if I take 180 minus 22.2, I will get what? 157.8, I believe. So we have to consider the possibility that maybe a second triangle exists with this being angle A. But think about that. If this were angle A and this were angle C, then my triangle would have more than 180 degrees of angle measure. So that's impossible. So this is one of those case scenarios where only one triangle exists. So once again, just to go through that, I do the inverse sine of this. I get the 22.2 for this one, so that's an answer for A. I consider the possibility of a second triangle by finding the angle measure from here to here. Knowing that this is 22.2, I take 180 minus 22.2, which is 157.8, and so that would be my C value, or my A value in a second triangle, but that's impossible because then these would add up to more than 180, and we can't have that in a triangle. So we know we don't have to worry about a second triangle, so that's nice. Now I just need to find angle B and lowercase b. So I can find angle B by adding up these two and subtracting them from 180. So if I do that, so you'll get an angle measure of 122 for angle B if you add those two up and subtract, if we do 3 sig figs. And so now I'm set up to find this using the law of sines. I can simply use the original, pair with a sine 122 over lowercase b. And so now I simply need to multiply these two together and divide by this to find my lowercase b. And you will get 460 for that value of b. So 460 is my missing side. So the orange ones are the ones I started off with, and the red ones are the ones we found. And that's all, and that's the end of your lecture. You will have a worksheet assignment to do on Schoology.